When running rigid nonmetallic conduit (RNC) from the meter pan to the service entrance panel, the question arises whether a separate grounding conductor is required, or if bonding the meter pan to the neutral is permitted according to National Electrical Code (NEC) section 250.92 bone. To address this, we need to delve into the specifics of grounding and bonding requirements outlined in the NEC. The NEC aims to ensure electrical safety by providing guidelines for proper grounding and bonding, which are crucial for minimizing the risk of electrical shock and fire hazards. Grounding refers to connecting electrical circuits or equipment to the earth, providing a low impedance path for fault currents to flow back to the source. This helps to trip over current protection devices like circuit breakers or fuses, quickly disconnecting the circuit and preventing dangerous voltage buildup. Bonding, on the other hand, involves connecting non-current carrying metal parts of electrical equipment and enclosures to create an electrically conductive path. This ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock if a fault occurs. Now let's focus on section 250.92 of the NEC, which deals with bonding service equipment. Specifically, 250.92b addresses methods for bonding service equipment enclosures. The section you mentioned, 250.92 bone, pertains to the use of suitable bonding jumpers or connection devices to ensure the electrical continuity of service equipment. It's important to carefully examine this section and related subsections to determine if bonding the meter pan to the neutral is permissible in your specific scenario. In general, the NEC requires that service equipment, including meter pans, be effectively grounded. This grounding can be achieved through various methods, including connecting to a grounding electrode system, such as a ground rod, ground ring, or metal water pipe. The grounding electrode system provides a direct connection to the earth, allowing fault currents to safely dissipate. When you use an RNC conduit, which is a non-metallic raceway, a separate equipment grounding conductor (EG) must be installed within the conduit to provide a grounding path for the meter pan. This is because RNC itself does not provide a conductive path for fault currents. The equipment grounding conductor typically runs from the meter pan to the service entrance panel, where it is connected to the grounding bus. Bonding the meter pan to the neutral conductor, as you mentioned, is a practice that is sometimes permitted under specific circumstances, but it's crucial to ensure that it complies with all applicable NEC requirements. In some cases, the neutral conductor can serve as the equipment grounding conductor for service equipment, but this is subject to certain limitations and conditions outlined in the NEC. Firstly, the neutral conductor must be properly sized and installed to handle the potential fault current. Secondly, the connection between the neutral conductor and the meter pan must be made in a manner that ensures a reliable and low impedance path. Thirdly, the local electrical inspector must approve the bonding method. It's important to note that bonding the meter pan to the neutral conductor may not be permitted in all jurisdictions or under all circumstances. Some local codes or interpretations of NEC may prohibit this practice, particularly if there are concerns about the potential for circulating current or voltage drops. Therefore, it's always best to consult with a qualified electrical inspector or engineer to determine the specific grounding and bonding requirements for your installation. They can assess the specific conditions of your project and provide guidance on the most appropriate and code-compliant methods. In addition to section 250.92, there are other relevant sections of the NEC that you should be aware of when grounding and bonding service equipment. These include section 250.4, which covers general requirements for grounding and bonding, section 250.24, which addresses grounding service supplied alternating current systems, and section 250.104, which covers bonding of piping systems and exposed structural metal. Understanding these sections will provide a comprehensive understanding of the NEC requirements for grounding and bonding. To summarize, when running RNC from the meter pan to the service entrance panel, a separate equipment grounding conductor is generally required to provide a grounding path for the meter pan. Bonding the meter pan to the neutral conductor may be permitted under certain circumstances, but it's crucial to ensure compliance with all applicable NEC requirements and local codes. Always consult with a qualified electrical inspector or engineer to determine the specific grounding and bonding requirements for your installation. By following these guidelines, you can ensure a safe and code-compliant electrical system. Now let's delve deeper into the specific requirements for equipment grounding conductors as they relate to RNC Conduit. As mentioned earlier, RNC is a non-metallic raceway, meaning it does not provide a conductive path for fault currents. Therefore, a separate EGC must be installed within the conduit to provide a grounding path for the meter pan and other equipment connected to the circuit. The EGC serves as a low impedance path for fault currents to flow back to the source, allowing overcurrent protection devices to quickly trip and disconnect the circuit. The size of the EGC is determined by the size of the overcurrent protection device protecting the circuit, as specified in NEC Table 250.122. It's crucial to select the appropriate size EGC to ensure that it can safely carry the potential fault current without overheating or causing a voltage drop. The EGC can be either copper or aluminum conductor, and it must be installed in accordance with NEC requirements. The EGC must be securely connected to the meter pan and the grounding bus in the service entrance panel using approved connectors or bonding methods. When installing the EGC in RNC Conduit, it's important to ensure that it is properly supported and protected from physical damage. The EGC should be run continuously without any splices or joints, unless the splices are made in approved junction boxes or enclosures. It's also important to avoid sharp bends or kinks in the EGC, as these can increase its impedance and reduce its effectiveness. In addition to the EGC, other grounding and bonding requirements may apply to the meter pan and service entrance panel. These requirements may include bonding the meter pan to the metal enclosure of the service entrance panel, bonding any metal water pipes or gas pipes in the vicinity, and connecting to a grounding electrode system. Specific grounding and bonding requirements will depend on the specific conditions of the installation and the applicable NEC requirements. Now, let's discuss the potential for bonding the meter pan to the neutral conductor. As mentioned earlier, this practice is sometimes permitted under specific circumstances, but it's crucial to ensure compliance with all applicable NEC requirements and local codes. The NEC allows the neutral conductor to serve as the equipment grounding conductor for service equipment under certain conditions, as outlined in Section 250.24c. This section permits the neutral conductor to be used for grounding purposes if it is part of a multi-grounded neutral system, and if certain other requirements are met. One of the key requirements is that the neutral conductor must be sized appropriately to handle the potential fault current. The NEC provides specific guidelines for sizing the neutral conductor based on the calculated load and the type of system. Another requirement is that the connection between the neutral conductor and the meter pan must be made in a manner that ensures a reliable and low impedance path. This typically involves using approved bonding connectors or lugs that are specifically designed for this purpose. It's also important to ensure that the neutral conductor is properly insulated and protected from physical damage. In addition to these requirements, some local codes or interpretations of the NEC may impose additional restrictions on bonding the meter pan to the neutral conductor. For example, some jurisdictions may prohibit this practice if there are concerns about the potential for circulating currents or voltage drops. Therefore, it's always best to consult with a qualified electrical inspector or engineer to determine the specific grounding and bonding requirements for your installation. They can assess the specific conditions of your project and provide guidance on the most appropriate and code-compliant methods. Now, let's address some common misconceptions about grounding and bonding. One common misconception is that grounding and bonding are the same thing. While both grounding and bonding are essential for electrical safety, they serve different purposes. Grounding provides a path for fault currents to flow back to the source, while bonding ensures that all metal parts are at the same electrical potential. Another misconception is that RNC Conduit does not need to be grounded. While RNC itself is non-conductive, any metal equipment or enclosures connected to the RNC must be grounded to provide a path for fault currents. A further misconception is that bonding the meter pan to the neutral conductor is always permitted. As discussed earlier, this practice is subject to specific requirements and limitations outlined in the NEC and local codes. It's important to carefully review these requirements and consult with a qualified electrical professional before implementing this bonding method. Finally, let's emphasize the importance of following proper grounding and bonding procedures. Proper grounding and bonding are essential for electrical safety, protecting people and property from the hazards of electric shock and fire. By following the NEC requirements and consulting with qualified electrical professionals, you can ensure that your electrical system is safe and code compliant. Remember to always prioritize safety when working with electricity and to seek professional assistance when needed. By understanding the principles of grounding and bonding and following the applicable codes and regulations, you can create a safe and reliable electrical system. The NEC is a comprehensive set of standards, and local interpretations can vary. Always consult with local authorities having jurisdiction, to ensure full compliance with all applicable rules and regulations. The information provided here is for educational purposes only and does not constitute professional engineering advice. Always consult with a licensed electrical engineer or qualified electrician for specific guidance on your project.